Wait, where are you going? Oh. I don't know why I didn't make that connection.
We're live.
Get it to a drive down.
So the smoke plume from the
Or just drive down there right after work.
Wednesday was pretty cool. See like where the top of the boundary layer is.
I'm supposed to go home today.
Just
go home.
Oh, was that controlled burning?
I think so, yeah.
There were 3 controlled burns in the same spot.
I was gonna say, and then the air smelled weird after.
Yeah, it did.
Yeah.
Yeah, I saw this, and this boundary layer was still, like the cap was still present at like 1:30 p.m.
Yeah, you can see it totally there.
I think it was insane that it hadn't mixed out yet.
Right.
See the boundary layer of it.
Anyways.
Okay, we can get started. Happy Pi Day. This is Weather Watch for Pi Day. I'm going to, rather than start with a recap, talk about what's going on right now, because there's a very interesting setup we have going on both synoptically and then mesoscale. So if you don't know, there is a big risk for severe weather today for Iowa, Missouri, Illinois, down towards Paducah. It slowly creeps up over us, not 100%, but there's a pretty good chance for pretty strong storms, so we'll take a look at that. That'll be one focus. The other focus, could we click on the fire, please? Fire extreme. There's 2 sides to this setup here. We have the severe weather, and then we have extreme fire conditions for portions of Kansas, Oklahoma, Texas. Could you scroll down just to the start of this text? There's something interesting. I hope that it's still on here. Yeah. Wildfire outbreak appears likely across the southern plains, which I've never seen before. So there's severe weather on the backside, there's wildfire outbreaks. So we'll take a look at what's causing all this, because it's both the same system and has had a pretty cool evolution.
So the other day they used the word historic.
Historic, okay, yeah. And there's already ongoing, we'll see ongoing dust storms over the places that are getting these wildfire conditions. So could we first start with the visible satellite? And I'll do the North America one, please. So this is a look at the current satellite. You'll see a couple things to note. One, we already have convection firing off, as noted by these clouds that rapidly develop and then move off quickly. We'll take a look at this, but none of the models that I saw picked up on this. So this will be an interesting thing to watch. How is this convection going to edit the environment, so to say, to either enhance or inhibit convection later on? Another thing, could we stop it towards the beginning here, like right there? You'll see if you look in Texas and Oklahoma, this is a dust storm going through Oklahoma and Texas right now. I have an uncle that lives in Lawton, Oklahoma, which is right about there. Dust. So, and you can see it if we start play again. You'll see it move. It originated over New Mexico and has moved across towards the west. You can make out where the cyclone is. If you follow the counterclockwise rotation or cyclonic rotation, it's right about Kansas, Oklahoma. You can see that's the spin, the atmosphere, producing both the fire weather, the dust, and then storms out ahead of it.
Excuse me.
Yeah.
Patrick, so you commented that none of the models had that initial line in Missouri. Is that,
Yes.
I mean, later in the forecast, I think they had a line there, but do you think this
They
is
do.
just earlier, or is it a totally separate feature?
It's a good point. I read some of there's a convective discussion about the place in Missouri where this is moving, and they note that this was not picked up. And there's uncertainty on if it's going to remain strong. This is not the line of storms that is predicted to be strong. We'll see that when we look at the models here. But so this was not predicted, this burst of storms, so to say. We'll take a look at the radar too. It's not particularly strong, but it is there, so it's something to note.
You know, back before there were TVs, when I was doing my PhD thesis, there was this thing we got during Gale, March 1986. It was a rain band that had convective elements in it, looked just like this, and it was out ahead of a dry trough, which is the dry line, with a low tropospheric barocclinic zone that sticks up. And so we found that was at the northeastern edge, the warm air advection edge of the elevated mixed layer. I wonder if that's true today.
That could very well be. We'll take a look at that.
And it's
Yeah.
elevated convection too in that case. It wasn't ground-based.
Exactly, yeah. You can see there is spacing between where this line is located and then where the really dry air is. So there's still, potential for really strong storms behind this initial line. On its backside in Wyoming and Colorado, producing snow. Same system that's sitting over Oklahoma Panhandle and Kansas. You can see ahead of it, here's flow off the Gulf of Mexico, bringing up really low-level clouds. This is really strong moisture. If you've been outside today, which I hope you have, you would have to be here.
Unless you slept in the building.
It is moist. It's, we have dew points in the 50s already, which hasn't happened this year. So it's moist and warm. The really moist air is down towards the Gulf, but it has made its way all the way up to us. And that's why we're in that risk for strong storms later on. Something also to note, the area where we have the risk for severe weather, it's sunny right now for the most part. So you can imagine strong daytime heating. We get moist, warm flow from the Gulf. This is bad news if you don't want storms. If you want storms, it's really good. So it's enhancing the risk for storms, yeah.
Right, so I like the word used earlier at the beginning of this discussion in terms of how this feature that's now in southwestern Missouri could sort of edit the forecast, change it.
Yes.
You
Yeah.
note the sun the sunshine that's there right now, the clear
Yeah.
skies, but those high cirrus clouds and maybe even mid-level clouds could then begin to dim everything and reduce the insulation.
Exactly. And it depends on how widespread this cloud gets. It's also moving pretty quickly, which I think there wouldn't be as much radiational cooling that you would expect if there was just a big cloud mass for a long time. So maybe it's not actually inhibiting anything. It's just probably temporarily reducing the stability, or increasing the stability, reducing thunderstorm chances later on. But it looks like it's, just in this loop, let's see, 2 hours, it's moved quite a bit of distance. So I wouldn't expect it to do much in the way of inhibiting storms.
Yeah, it's conspicuous that the distance between that band and the front edge of the dust swirl, which presumably is at the lee side trough axis,
Yes.
is
Yes.
consistent. It makes me think that's what's going on there.
Yes.
There's something really three-dimensionally interesting there.
Yeah, completely agree. Maybe that's why the mesoscale models didn't really pick up on it, because it's more of a synoptic scale feature. I don't know. One other thing I'll point out, because it's not going to last long, here's snow over the northern Canada and then the northern United States, particularly the northeast, all the white specks, that's snow. As we keep getting warm, continued warm through the spring, you'll see that disappear as we go forward here. And the west is kind of, because we have this trough, which we'll see sitting over the west, these are all a ton of clouds and snow cover. It's kind of hard to make out what's exactly going on, but we'll look at some of the things going on there as well. Could we switch to water
Just
vapor?
1 second.
Oh, yeah.
Look at the cloud eater thing that's going across northern Venezuela. And you can go all the way out into the ocean south of the Lesser
that's-
Antilles.
yeah.
Isn't that interesting? What
That
the
is.
heck is that? It's just
I have
coming
no
across. It's
idea.
like pulling a screen down that says no more clouds here.
True. That is very weird. It's very linear,
Yeah.
too. Yeah. I have no idea.
Can we produce a map do we have maps that are created in real time?
Not that far south, I don't have.
Maybe we'll look
Surface
at
map?
it.
Okay, certainly.
Yeah, I've just got it here.
Can we look at water vapor? Maybe we'll see something in the water vapor that hints at that. And I'll do the enhanced ones. Yeah. So if we take a look, this is sort of reflecting what we were seeing. The reds, yellows, oranges, that's really dry air compared to blue and white and green. This is the satellite looking down. It's picking out the layers. It's seeing moisture. So colder temperatures, more moisture higher up. And essentially this is looking at the surface, so it's incredibly dry over Central America, whereas where we have storms, there's a lot of moisture, so it's seeing it higher in the atmosphere. This is the band of storms we saw firing off. You can see two areas of really dry air contributing to this historic fire outbreak. First, there's flow over the terrain, the plateau desert in Mexico. So you can see that the gravity waves are perpendicular to the flow. That's moving over Texas, as well as there's a band of lee-side subsidence that produce this really strong really dry air right here in Oklahoma and Kansas. Both of those contributing to the dust and fire conditions over Oklahoma and Texas. You can see where it is snowing, we have more of those cloudy features, moisture higher up. Here is we had thunderstorms overnight. There was still thunderstorms ongoing over the UP of Michigan and the Arrowhead of Minnesota. Temperatures in the 30s, and there's thunderstorms and hail, which is pretty cool. And there's still snow on the ground in these places. So you can imagine that's probably pretty interesting. But that's what produced the wet conditions overnight, and we've had the clearing out ahead of it. Even some drier air out ahead of these line of storms here that's firing in Missouri and Arkansas right now. And we'll see some of that. You can also see the swirl pretty nicely show up in the water vapor moving from Texas Panhandle into Oklahoma and Kansas here. And this system, if you track where all the features are coming from, a portion of it extends, I believe this is Manitoba, northern Manitoba, all the way down to Baja, California. Same system. You can see it wrapping all around here. So very impactful storm. One thing that I'm noting here, looks like another swirl moving on the shore of Oregon and California. I'm not going to touch on that at all. I'm just going to focus on this specifically, but very impactful. It's impacting much of the eastern United States, east of the Rockies here. Okay, so that's the satellite. Can we go to the super peaks, please? And I'll start with 250. So we'll look at the jet stream and its orientation relative to what's going on. First, you can see we have a very deep trough, extends from Canada all the way down into Mexico. It's negatively tilted if you draw the trough axis like that. Jet streak is on its downstream side. So right where the minimum and sea level pressure is located, kind of in a jet exit region. It's also sort of not really in the jet exit region, so it's unclear if it's being affected by this jet at this time, but we saw a nice trail of moist high moisture coming off the Pacific over the plateau south of where we saw those really dry conditions. That extended over the southeast here. Nice area of diffluence out ahead of it, where we have potential for storms later on. You can sort of also see the boundaries between where it's winter. This is more the polar jet up in Canada, and where it's spring and then summer. So this explains why we've had warmer temperatures, is because the jet has retracted towards the north, allowed us to get more warm than we had been, and you can see there were colder temperatures up to the north. That's where the snow cover is. We're in this nice springtime region, and then summer, where we'll see is down in Florida, it looks like, from the jet stream right here. So one thing to note is that really strong, deep, negatively tilted trough here. Let's go to 500, please. So go a little closer to the surface, look at troughs and ridges, and there's our trough. This is the thing that's producing the cyclone at the surface, all of the nice weather going on. You can see it's negatively tilted as well, really sharp curvature. There's a temperature gradient represented by the red dashed lines, and there's drier air and colder air advection right on its trough axis right there over New Mexico and in Texas. So this is from 7 a.m. So these conditions have probably moved and shifted over Kansas, Oklahoma. That's right where we saw that dust production ongoing. Out ahead of it, nice diffluence again. Not too much of a temperature gradient out ahead of the trough, but what is to note is it's relatively warm all through, and uniformly warm all through much of the Midwest and then down into portions of the South here. So this is also setting the stage for severe weather. We have a nice trough, nice ageostrophic diffluence or divergence out ahead of it, producing that cyclone, and that's relatively warm even at upper levels compared to, especially in the trough axis and behind it. These are some of the warmest temperatures I can see on the map here. So that's leading to some of the severe weather potential. It is also, we have a slight wind shift from more zonal to slightly meridional, and so I'll keep pointing that out as we go down further at this case here. So let's go to 850 now.
Too bad that the cloud head is getting a slow start. Because if it was
Yeah.
a better cloud head across Kansas and parts of Nebraska, you'd have even more ridginess downstream of the trough.
Exactly.
Massive
Yeah, we don't have
evacuation
that
mass. This thing's kind of not all organized yet. So.
Right, right. It's still strengthening. This whole setup is still strengthening here. At 850, very close to the surface, you'll see we don't have observations because we're in the mountains over the west, but right in the lee of the mountains, we have a lee side trough, also aiding ascent out ahead of it. We saw that cyclone somewhere in Kansas, Oklahoma, so right downstream of the trough axis. One thing to note from this, it's very obvious, it's pretty warm, extremely warm actually. We have 17 Celsius all the way in Kansas, 18 I believe in Omaha. This is 7 a.m. So there's potential for these temperatures closer to the surface to get warmer and warmer. We'll see that reflected in the surface map, but you can also see there's flow straight from the Gulf. And so all of that flow coming up, producing, or giving more moisture and relatively warmer temperatures out ahead of where we saw the cyclone developing. All of this creating more convectively conducive ingredients for the severe weather going on. There's also, we'll see this in the surface map, you can see there's a nice temperature gradient and wind shift behind where we have that warm air. This is the sinking and really dry air behind that lee side trough. This is helping all the fire conditions. And that boundary at 7 a.m. was like right where we saw the dust in Texas and Oklahoma into Kansas. So that's another thing to note. You can also see how this is just a very broad trough extending all the way from Colorado into Manitoba. This is one system producing all these impactful weather all over the United States.
Patrick, so,
Yeah.
question, John, I'm just wondering about, what do you make of this, I consider it an odd structure that extends north from the 850 cyclone into southern Canada, that broad trough. Is it a lee trough from historic subsidence? I looked at this last night and I couldn't really figure out what the origin was for that.
That's a good question.
'Cause there's no westerly flow at that level that's of any appreciable strength.
No, there's not.
Anyone?
I'm not sure.
I'm not, me either. It's mystifying to me. I got other things about this whole thing that are really challenging to talk about in a minute. But yeah, that's a really good question. It looks like kind of a classic weak baroclinic wave over Lake Winnipeg and the border of
Yeah.
Saskatchewan, but it's not easy to say where it came from.
So is it it could be just two separate weather systems? That's
Yeah,
what-
yeah, yeah, I think-
Maybe we could.
That's what I was just gonna
animation,
say. Yeah, we'll see this at the surface, but there is a secondary cyclone up right in the North Dakota
Yeah.
Manitoba border. So it might just be that the two are close enough together that
It looks like-
like one of them. It's all from the same setup, but I think there is a low-level circulation, maybe just distorting it enough to look like
We
that.
do have a lead loop of this if you want to.
Yeah, we could do
Yeah,
some
let's try that,
good.
'cause, you know, these things are known as inverted troughs, both sides of Kashishi and I think 85 or someplace like that. But there's not much discussion about what generates the pressure fall in the northern branch of that. And so, 'cause sometimes it is historic lee side
Right.
subsidence, but
Yeah.
that seems like it's kind of not at play, given the fact there wasn't strong westerly flow. And there's tremendous periodicity there, which is interesting.
Right,
Yeah,
so what Patrick was
absolutely.
saying about maybe two separate systems might be on all
Yeah,
ends.
it looks like there's
Yeah, there's a little
there's
right there, yeah.
one that moved just over the Rocky Mountains of
And
Canada, and
it
then
gets
this
lost in the
one.
mountains.
Yeah, exactly. This is the intensifying one down here. So if we go one forward, you'll see, here's one, here's another one down here.
Yeah, and how about at 500 millibots? Because I know that the one over California has a really strong upper front. I don't remember what was going on in the Pacific Northwest at the same time. That could be interesting too.
Yeah, let's see. Here's a, okay. Sort of, it's part of the same trough.
Yeah, it is, isn't it? Yeah.
Thursday, can we go forward to like Thursday, 12Z, and then one more? Interesting. So it's all part of the same system. And then
Yeah.
it seems like this one just develops much stronger than what is going on to its north.
Right, but that in British Columbia, Alberta, in that area right there, there's like probably a little local vorticity maximum.
Absolutely, yeah,
Separate.
yeah. So I wonder if that upper front just came down and this one went to town, whereas this one just remained neutral strength, essentially.
Yeah, just didn't really take on the same development characteristics.
Yeah.
And then this is this morning, and then the one further off at the longitude of the Aleutians looks like another strong upper front candidate for development.
Yes, that's right.
And the,
Yeah.
you know, that's the one for, I don't know, when is that, Tuesday or
Wednesday,
Wednesday?
Wednesday,
Yeah,
Thursday,
yeah,
it's a
snowstorm.
Yeah.
We said at the same time.
Bring it on. Bring it on, B-I-O.
Could we go to the surface now? And so we'll see a couple cool things that you don't see all the time at the surface here. So first, we go near Panhandle, Texas, Oklahoma. Okay, you'll see, so we have a nice wind shift. We saw that dust. Capital D stands for dust in this case. So there have been, I believe it was Amarillo, which is one of these two stations
It's
here.
more than one, yeah.
Northern one, has had dust since last night.
Wow.
So they reported dust for several hours here. All of these locations though, this is the leading edge of that dust storm. You can see haze being reported, most likely dust. A nice gradient in the moisture. We have dew points in the 30s, 20s, teens, single digits, and then in the 50s and 60s right ahead of it. So that's that boundary, really strong subsidence producing those really dry conditions in the dust. You can see the winds also pick up significantly where we have 15 knots in Oklahoma. You just go to Panhandle, Texas, this is 30, even 40 knots, 45 knots right in New Mexico, blowing dust. So you do not want to be driving if you are, I mean, no one's going to be there today, but something to watch is this dust progression as it moves across Texas, Oklahoma. Last week, I believe, we had the same sort of conditions, except the flow was mainly northwest, southeast. So there was a dust cloud that moved from New Mexico all the way down to Houston. So this is sort of the same system, it's just, or setup, it's just moving southwest to northeast in this case.
It's a good time of day for this, because you know, the upper front's deep right there over
Yes.
the Mexico-Texas border, and it's a really sharp upper front, probably goes down to 700 millibars or deeper by itself.
Yeah.
Boundary layer is deep because it's 12 noon.
Yep.
And you're exporting air from the jet down to the ground.
Easily, yeah, and we saw that
And it
jet
hasn't rained
sitting
there.
right over that same region here.
Another interesting thing is over parts of Missouri where that line of convection that you saw, it's clearly elevated because those dew point
Yeah,
depressions are
exactly.
pretty weak, and I'm wondering if that's going to sort of kick the knees out from under that and just allow that to weaken.
It could, yeah, it totally could. And this might be, on the other side, might be good for any convection later on, because if you have any falling moisture that makes it through this dew point depression, you're going to saturate the surface. And that's what you want to get that initial push for any ground-based or surface-based convection here. So might be doing both at the same time. We'll just have to see how it plays out. I'm looking here, northern Missouri, 79 degrees already, 77 south of Des Moines here. We're at 70, so this is the warmest day of the year by far for us. Potential to get to 75, which is like temperatures mid-May, late May,
Yeah,
and
early
it's
June.
early March, early to middle March here. We can see the cyclone situated somewhere Kansas, northwest Kansas. 977.3 is the lowest pressure I see from this cyclone right here. This is the main player in town. Here's that other cyclone I was talking about, located in North Dakota. 60 degrees in, I think this is Fargo. One of these is Fargo. 60 degrees to 37, and a nice wind shift too. So two systems, this is the one we're talking about here with the really strong storms. We're 70 over 47, so pretty moist, warm. We'll continue to see that warm, moist flow throughout the day. Nothing's going to impede it. You can see it's all the way down towards Mississippi, so we'll just keep getting warm and moist, and that'll just set the stage for storms later on, specifically over us, but also portions of Missouri, Illinois, and Iowa, where we saw that really strong chance for storms here. On its backside, I noted, here's Colorado, snow, temperatures in the 20s and 30s. All from the same system. Even in Wyoming, there's some snow too, so. Very impactful storm.
All right. Also interesting to note that parts of northwestern Minnesota and eastern North Dakota, I think, are under winter storm watches.
Yeah, right. Winter storm and it's 60 degrees outside and sunny. So that's always fun. It's extra fun when you get like a tornado warning or severe thunderstorm warning and you're under a winter storm warning at the same time. Yeah, pretty cool. Okay, so that's the surface. now could we go to pivotal, please?
Oh, could we see?
Or, yeah,
I just want to see the 700 millibond map. That was
Oh,
the
yeah,
one that
yeah.
was crucial for us when we were looking at this pre-dry trough rain band all those years ago. And I don't see any really strong baroclinic zone. There's it's over Texas Panhandle.
Yeah, right
It's
here.
not as far east as I thought it might be. But if I took my own analysis, it might be slightly different, but not much different. That's a pretty good analysis.
Yeah, I would completely agree.
So maybe the mixed layer is just higher. Maybe it's like at 600 or something. I don't know. But
It could be.
anyway, it's
Yeah.
can't do it quickly. So thanks.
Yeah.
Yeah.
for showing that.
Also look at a radar before.
Yeah, I was gonna go, I forgot the radar. Could we do the radar composite, please? So we'll see those storms that were over Missouri. So here's that nice line, first line of storms developing. If you've looked at modeled storms, you'll see that this is sort of the linear band we're expecting today from this system, especially over our region. There's just been a nice band of precipitation forecasted for several days in a row now. This is exactly what's happening, but this is not the main rain event that we are expecting later on. You can even see it's kind of dying too, especially over middle Missouri where it just breaks up. But this is the storms we saw. Here's the thunderstorms overnight that have still over the UP. Here's that snow behind the system here. This is all from the same system, and then here's the thing moving onshore over California and Oregon there. Other than that, there's nothing else going on. It's just, this is the main player for today. Earlier on, you could see the dust on the radar. I don't know if this is dust or not ahead of some storms or anything like that, but there was dust on the radar being picked up. So being lofted enough, high enough that the radar could see it. Pretty cool. Okay, could we go to pivotal, please? And I just want to look at some soundings valid right now. And I'll use the NAM, please. Yeah, so we'll do 6Z NAM, and we'll just look at the setup for some of these conditions here. So we can do the 12Z run, and then could we do this? Yeah, and then let's go to 18Z, please.
6-0.
I think 6 hour forecast. So this is a valid right about now. Nice job with the forecasted minimum sea level pressure. That's exactly what we saw in northwest Kansas. So pretty good. You can see this model, the NAM model, does not have those storms being produced over Missouri, Nebraska, Iowa. If we switch same time, let's go to the convection allowing, let's go to the HER model. You'll see maybe it's picking up on something, but earlier runs, if you go back 1 hour, this is not there. So maybe there's some storms, definitely not as strong as they actually are occurring. If we go to another model, let's do the NAM 3K, nothing. So none of the models picked up on that little band of rain that we saw. So that's interesting. And then if we go back to the NAM model, and we'll just look at the soundings here. We'll click on like middle Missouri, place where we expect really strong storms. You'll see a couple things to note. We have nice warm air advection in the low levels, indicated by both the veering winds and then these red little boxes also indicate the warm air advection. You can see winds get really strong just around like 850. We have like 50 or 60 knot winds already. Decent amount of cape, as noted by the parcel trajectory, and this is right now, so this is before storms are expected to fire up. Very conducive for potential for pretty strong storms going on. Also to note in the photograph, you can see the veering as it extends clockwise away from where the surface is located and just going up and up and up. You can see that nice profile. Good for storms to rotate if you have this sort of profile right here, and it's only 18Z, so there's potential for these to grow and all these things to get stronger and stronger here. If we go exit out of this, we'll look at maybe Iowa at the same time, so a little farther north here. We see sort of the same thing, not as a strong clockwise motion to the photograph, but we see very deep warm air advection, all the way from the surface up to like 600 millibars. And you can see 73/54, so it's warm and moist. If you lift this layer here that's near the surface, you have something like a front come through, you are good to go in terms of convection. There's also a decent amount of CAPE, as noted by the parcel directory here. So all these things conspiring to produce eventual severe weather as we get something to lift the moisture and warmth from the surface here. And then let's look over us. And this will be the last thing I show here. So this is Madison at the same time, pretty good. For the model speak, we're at 70 degrees as noted by the surface odds, 69/51. We also have really strong warm air advection, essentially through the entire troposphere into the stratosphere here, which is interesting. And we have nice low-level veering. So we are also under the gun for severe weather going forward. Not as strong as that Missouri or Iowa soundings I showed, but there's still potential if those storms hold to hit us and be pretty strong after dark here. So something to note, something to watch. And then I'll just end here. Could we go to the SPC that I had again at the start? And we'll go back a click, and we'll just look at the hazards. If we click on the severe, moderate right here. And so you'll see here's that moderate I showed at the beginning. If we go to tornado, it's mainly the southern portion into Missouri, Illinois, down into Tennessee. That's under the gun for tornadoes. If you go to the wind, it's mainly that northern portion, Iowa, central Illinois, northern Missouri, even creeping its way into our region. So we're mainly under a wind threat at this time. But of course, any storm can rotate and produce a tornado. We saw that last February, where you need if we go back to tornado, we were under a 2% tornado, and we got a couple tornadoes. So any of these storms could produce potentially significant weather. Just something to watch as the day goes forward here.
And hails.
Yeah, and we can end on hail too. So mostly that southern portion, but we're still, potential for some significant hail here. That's the current weather. Any questions or comments before I hand it over?
Yeah. All right, thanks, man. Pete, can we plug this in quick?
Yeah.
Real quick, as we say here in the Midwest. No need for that extra app.
This is what we want.
Yeah, just quick is quick. But real quick. All right, thank you, Pete. Can we, let's start here on the, I'll do it.
I was just going to say that.
Yeah. So we got protested out of talking about the end of the cold pool last week, which thanks for going downtown. That was really important. We're the 9th warmest of all time. We needed to have this drop-off of aerial extent start about early February, and it didn't. We're pretty cold for much of February, and then there was a rapid drop-off. So highly volatile year, 7 straight days in December with all-time minimums for the calendar day. It's never happened before. I've never had more than 3 straight, so 7 straight is just in another world. And then after that, from January 1 on, it was kind of a normal late half of the 20th century winter, but then a little bit of a warm-up at the end. I just wanted to say something about this storm that's coming, because it's really interesting in a lot of ways, and I'm not going to spend a lot of time showing you too much, but I'll start here. This is the 12-hour forecast from last night's 0Z run, so this was valid 12Z this morning, of 700 millibar QG omega. This is the ascent region. I can't even count how many decipascals it is. It was something like on the order of 15 to 20, and then a strong descent region, really strong couple. So that's the total omega. Then let's look at the Sutcliffe-Trenberth version of that. Looks just about the same, doesn't it? This is the PVA by the thermal wind. Extreme ascent, extreme descent, and they're in just about exactly the same spots with roughly the same magnitudes. Looks like what you expect. The predominant forcing for driving cyclogenesis, in my book, has always been the PVA by the thermal wind. That's the thing that really drives it. And the rest of the omega equation, the deformation terms, is often just an adornment. It doesn't really drive the bus. Boy, oh boy, is that changed at this time. This is 18 hours, so valid tonight. 6 p.m.? No, noontime, sorry, valid now, sorry. This is the PVA by the thermal wind, currently ongoing as this storm gets organized in western Kansas and the Oklahoma Panhandle. 1, 2, 3, 4 decipascals per second. Pretty strong subsidence, but that's it for the PVA by the thermal wind. It suddenly doesn't appear as a major factor. Here's the deformation forcing. Oh my God. That's 1, 2, 3, 4, 5, 6, 7, or 6 at least, and very concentrated. First time I've ever seen this, that the deformation term in exactly the location of the development region is contributing more than the PVA by the thermal wind. And this is just 700 millibar omega, so it's possible that it's an anomaly in the vertical and it shows up at 700. I haven't investigated it further, but I have a suspicion there's something weird going on in this development, or weird in the sense that I've not seen it before. So, coincident with that, that's caught my eye. That's really interesting. Coincident with that, here's the 12Z forecast, 15-hour forecast from, I guess, from the same, did I initialize? This was initialized at 6Z, so not 0Z. Beautiful warm plume up here this morning at 9 o'clock. Look at what happens at the next time. If I can read it, at 18. Oh, I'm looking at, I gotta go.
Yeah, I think you want.
I want 12.
That's 9.
That's what you had before.
Something.
Want me to get it?
Yeah, could you? You can see.
I'm watching up here.
12.
What happened to the warm air? Look at the time of day. This is from 9 a.m. to noontime, local time. All this air at 850 has disappeared, that warm air. Now, one of the mechanisms, of course, is ascent. You cool by ascent. The whole structure of the thermal field's changed, coincident with an entirely different forcing, which depends to some extent on the construction of the thermal field. So there's something really interesting going on here between 12 and 18Z today, when we start out with a dominant PVA by the thermal wind couplet driving the development, which is common. 6 hours later, it vanishes comparatively compared to the deformation term, which is usually, you know, the kid brother coming along with you. And the whole thermal field collapses. I don't get it. So anyway, that's all I wanted to say. This is a special storm that we're about to experience in a lot of ways, and that is a real mystery to me.
You don't think it's just that the ascent?
Ascent happens all the time. I'm not sure
To
why.
cool it off, to cool it off, yeah.
But yeah, I mean, yeah, you're right. I mean, that's probably why the thermal field goes away. But then why does the deformation term rise in prominence at the same time as the complete reconstitution of the thermal field? I guess I should say it that way. That's what's mysterious to me. They seem interrelated in a way that goes beyond just the thermal field collapses because it's strong ascent. That's right, you're right. It's vertical advection of theta. I don't know how come the deformation term takes on prominence. And I don't know that it does in the 3D, but I'll have to check that out. So I just wanted to show that. I'm done. I'll take this away. No, I didn't.
You want me to pull that up, Michael?
Or unless you already
My
have it.
email.
Okay. We don't need a rule, okay. So today I'm really grateful that Patrick led us through the discussion of the mesoscale discussion. I'm not a convectologist, if that's a word. I don't look at things on that small a scale, but I was going to say a few words about it, but I think Patrick has really done an excellent job in sort of setting the stage for that discussion and also leading us through some of the factors that contribute to this significant storm. But a couple things I wanted to point out. This was in an email that we got last evening from the MAC mailing list, which I thought was pretty interesting, which was, Patrick was commenting on the intensity of that trough off the West Coast. This was a valid, a forecast valid for 6Z this morning. This is a 192-hour forecast. You know, I always like to go well out into the future. And then this is the analysis. And this is actually from, I guess, all the global models did a fairly reasonable job with this over a week out. And we often say, well, that weather system's over the Pacific, we'll wait till it gets into the network of observations in the continental United States or North America. That's not really the case that much these days. It's because we have satellite observations, some of them processed in this very building. So we can't have skillful forecast even more than a week out. And I want to say this is an exception, but this is pretty incredible. This is from the AIFS, which is the now operational ECWF forecast model. And again, there are may be important depending on where you live, differences, but in terms of the broad scale of this, capturing such an intense upper trough that far out, I think is pretty remarkable. So I just think, just to point that out for the forecast. Next thing I'd like to move toward, thanks Pete, is I think it's going to be the second tab, the fourth tab. This is the hazards outlook. We're going to look at multiple scales today. I guess before I do that, I guess I have them backwards. Well, these are the big things here if we scroll down just a bit. The rapid onset of drought is expected in sort of the 8 to 14 day time period. We'll kind of telescope in to a shorter time period. So this is an area that's already experiencing this dust storm and we know dry conditions. It looks like things are going to get even worse for this particular area. Again, this is brought to us by the National Weather Service, Climate Prediction Center. If we just get rid of everything from products to the right,
Keep products or get rid of?
no, get rid of everything, yeah, products to the right. And look at sort of the, first look at the 6 to 10 day temperature forecast and then precipitation. Again, for us, we're kind of in this likely being above normal temperatures for the next 6 to 10 days. Pretty chilly out in the western part of the United States. New England experiencing some warmth. And for precipitation, we'll see we'll be slightly above, I shouldn't say slightly, we'll likely be above normal for parts of the Great Lakes into the Mississippi Valley and dry over the southwest where that impending drought conditions beginning to take over. And wet also over the Pacific Northwest. West Coast often always needs precipitation, so this is great for them. Okay, we'll go back a click and the hazards outlook. Or did we just start with that? I'm sorry, we just started with that. Risk of high winds in this later in March or the next 8 to 14 days. Since I'm more familiar with this product, I think that's not going to be the one I want, but just click on it for a second, please. Yeah, I'm not going to go there. Let's go to Pivotal and go to the forecast and just look at the array of watches and warnings and things of that sort of first tab for this first area right here. So a pretty well lit up map with all sorts of hazards. We talked earlier about these places up in northern Minnesota, northwest Minnesota, eastern North Dakota. Temperatures already in the 60s this morning, and they're under winter storm watch for later tonight into tomorrow for some significant snows possible. These red areas here are purplish areas, red flag warnings, strong winds, dry conditions, likelihood of fire. In the browns, we have high wind warnings with this rather extreme storm. We could scroll down a little bit just to make sure I get this just right. And high wind watch in sort of the dark brown areas. So a pretty active map and flooding possible in central Tennessee, northern Mississippi, and Alabama. So pretty active day already. And I guess there's some severe thunderstorm warnings that have already begun to pop up. But it's unclear exactly based on the color scale, because they look very similar. But I imagine they'd be somewhere over Texas perhaps at this point. You might see that on the SBC page right there. Yeah, that could be it. So winter weather, spring weather, this is a pretty sort of, I guess, outrageous. But look, this is a fairly significant part of the country being impacted by weather, right? Just going back to something we talked about a couple weeks ago, this is an example of a day where you need a fully staffed forecast offices in many places, as well as some of the national centers being fully staffed to be able to provide folks with timely watches and warnings, advisories, et cetera, for the impending weather hazards. So grateful we have those folks working today, and hopefully lose more of them. In fact, we need more. Okay, so let's go to the very first thing. We'll go to Pivotal. And I want to just look at one thing. We already saw it's 70 degrees outside. Let's go to the models. We'll go to GFS. And let's zoom in for just a moment. If the zoom in is not really necessary. Regional.
We gotta use orange on those threat maps. There's risk from orange. I mean, really, something on orange, really the highest risk
Right.
level.
I got you. All right, so we go right in the middle of Dane County. And this is just a sounding. This is 18Z sounding. If we go back actually to, if we can do 0Z. Oh, we don't have to do it from there. We can do it from the map. Click here. Just to go back as far back as we can go. Or even, this is going to be fine. This is 3, okay. So this is looking at the, our warming up today. If we were to sort of just extend this temperature profile from the top of the boundary layer down to the surface dry adiabatically, that gets us into the low 20s in terms of degrees Celsius. That's at least 68 to maybe into the low 70s. But depending on how deeply we mix this out during the course of the day, is going to influence on just how warm we could get. Could we get into the mid-70s? Again, 82, 83 is about the maximum temperature on average Madison gets during the calendar year. That's in late July, in mid-July 18th to the 21st of July, around that time period, climatologically. It's about 82, 83. So we're looking at warmth that's more characteristic, perhaps, today, that could be more characteristic of mid-June than it is mid-March, which is kind of neat. Let's step forward and look at how the sounding evolves over time. We saw that there's some modest varying of winds. Some of that could be just boundary layer friction, but we are getting really strong southerly flow. As we go forward in time, a few more clicks, Pete, that's at 18Z. The model temperature, explicit temperature is 71 degrees. We may get a bit warmer than that. But if we were to even just go, mix even deeper, that would get us, closer to, perhaps mid-70s. Let's go ahead one more time frame. Get 73 or whatever. But we could, again, there's still a little bit of the residual part of that inversion that's been weakening over time. So mid-70s is not out of the question, getting up to 75, 76 today, which would be just fantastic. But we're going to go from sort of a early spring or false spring day to back to winter conditions with wind chills, at single digits above and below 0 Celsius by the time we get to, I did that deliberately, by the time we get to, Wednesday and Thursday with accumulating snow perhaps. That's kind of an interesting change that's going to occur here. But in the short time period, let's go to a convective allowing model and look at the timing of when those thunderstorms are expected with that line that's going to develop. Maybe first we'll just back out of this from regional. We'll come back to the zoom in a moment, but we'll back out from regional to just the national map and look at the latest HRRR that's running. That's the high resolution rapid refresh model run by our weather service operationally. And let's go from 12Z, let's look at a more up-to-date model. I think 16Z's in. I think it goes far enough out for us to see that. So let's just step ahead. We can go almost hour by hour with this. Look at the development of that convection over the southern parts of the United States, just to our southwest. So here's the line that was expected to develop. This is by 21Z, beginning to enter into eastern, just east of Kansas City, Kansas, moving into western Missouri. If we step forward again in time, we see this line develop, sort of initially starting off as, I guess, so-called discrete cells, and then kind of consolidating into more of a linear band of convection. So we can keep stepping forward, please, with that. And so it's along the edge of this push of cold advection where we're getting this convective
storm structure.
So, I'm sorry?
It's a weird looking storm
Yeah.
structure.
If someone said, "Hey, I've made a model, John."
Yeah,
here's
sorry,
my first
back to the
forecast."
drawing board on that.
Right, this looks
It's not
a
working,
bit bizarre.
obviously.
But here are these convective elements. So now we're at 1Z, which is, 8 o'clock? So still to our southwest. But no, this is the area that's expecting perhaps some severe weather. We saw the wind threats on the northern side of this and more tornado threats, as these still a bit more discrete to the south, on the southern part of this band. Looking at the models at least earlier before Weather Watch, it looked like the timing for this band to reach our area was sometime just around midnight or so. And so we'll see if this reaches sort of western Dane County by around 5Z. Let's now go into the regional mode and look at a couple of different aspects of this. First, in terms of the reflectivity or assimilated reflectivity, then we'll look at winds and temperatures. I'll do this pretty quickly. So this is really neat. I mean, if you talk about models and things that look weird structure, you can even see some of the implications of having this convective band. You get, it's actually a bit of a pressure ridge here with the cold air outflow from this convection. But here is 5Z, just about midnight, and that convective line is just reaching into Dane County with the thunderstorms. And this goes by fairly quickly in this forecast. We go ahead, a few more clicks. It's out of here within about an hour and a half or so. and then we're pretty dry, and we stay windy. So the first precipitation event that we're gonna get with this storm is gonna be with that convective band sometime around midnight or so. If we look at if we go back to 5Z, go back to the 12 hours or so, just before it is getting there. Let's look at the winds. And again, you can see from this, again, convective line model, you can even see the strong divergence at the surface, the ridge that's forming as well as this band begins to move in. So you can see, go from brisk southeasterly winds to briefly those winds aloft being transported down to the surface. So this is the opportunity for us to get some fairly strong, significant winds with those thunderstorms when they pass through early tomorrow morning. Okay, so that's the first band. Let's back out of this. We'll go back to the GFS, national view, and look at a couple other things. I know time is getting somewhat limited. And we'll go to 24 hours in the forecast, and we'll go to the surface, more traditional surface map precipitation, please. Okay, so once that convective band is passed out of our area, we still have the low, fairly significant cyclone at 977, just southwest of La Crosse by tomorrow morning, with some precipitation associated with it. And with this broad cyclonic flow, if there's still significant moisture in the boundary layer, we're probably going to have a lot of convective clouds, perhaps low clouds. Not going to be very deep stratocumulus over us, keeping us fairly cloudy with some maybe breaks at times. Here's that intense snow band that sets up well to the northwest of the cyclone over parts of Minnesota. By this time, I guess the precip has ended over the far western part of Minnesota, and that band is now moving into central Minnesota at that point. If we step forward, we'll go just 24 hours because I want to get to another event that's about to occur. Cyclone weakens, moves out to the north and northeast, and we're in cold advection on the day Sunday, so Sunday, clearing perhaps, but with some maybe light snow or sprinkles, particularly in the morning, as this weather system moves further and further out. Go to 72 hours Monday morning. Strong warm advection day, we're going to warm up again. What's this about snow? It looks really nice. Warm advection on Monday, and we could do a sounding. Let's take a sounding for Tuesday, 12Z. Okay, start off chilly. I mean, if we, even this is a fairly significant inversion, and we have clouds perhaps beginning to encroach. But even on Tuesday, we could get, if we bring this dry directly down the surface, I want to make sure I'm following the right line. If we could mix out, the winds aren't as strong, you could still even get up to near 60 or the mid-60s on Tuesday. That's Tuesday, and this is only Tuesday morning. Let's step forward just here, just a couple to see how warm do we actually get. This with cloud cover, that's also going to limit the mixing. 50, and now we're at 18Z.
60.
Okay, so we did get into the 60s, 62, so not too bad. And you can see this is pretty dry adiabatic. We didn't really mix out the entire inversion, but we get up into the low 60s, which isn't too bad. And southerly winds. Okay, back to the map. By the time we get to Wednesday, we have a nice cyclone beginning to develop. And it's pretty decent intensity. As you've seen me all this semester, it's been about, I love snow, bring it on, as John would say, I would say that. And, we have a band of heavy snow that sets up well to our north and west. We're in the rain. Let's just go by in 3-hour increments. We'll just step forward. What's that? This is an old cutoff, not non-tropical.
Please, let's not be diverted by that.
Oh, no, that's too far. Oh, that's way too far. We're gonna go hour by hour. 989.
Yeah.
The cold air comes crashing in, and our precipitation changes from, at least in the GFS forecast, from rain to snow. And that's probably solid snow. We can even let's do a sounding at this point. This is Monday afternoon, 4 o'clock. 28 degrees, dew point 27. Just loving it. Look at northerly winds. Saturated, well below zero.
Isn't there a box somewhere that says probable precipitation type? Yes, there it is.
Oh, come on, okay, John. I mean, who would have thought it would be anything else? All right, let's go ahead and get out of this.
Still hiding the truth somehow.
Okay, let's go ahead. One more step in this. 32, and there's more snow.
Yeah.
Curious little, look at
What's
that little
that?
tense
Yeah.
little beast there. If we go back just
It's the Kankakee
3 hours for
cyclone.
just a second. That's the old cyclone, and it's just not labeled anymore, that's all.
Yeah.
Nothing special about that. 135 hours, and the snow is over by the time we get to late evening on Thursday. How much do we get?
70.
And we'll look at just first the total amounts, and then we'll look at the amounts on the ground, but again, time is really short, and we'll zoom in, because this will be interesting to look at. Oh, man. Time-wise, I have a bunch of other things I want to show. So, 6.4 inches is the expected total by this particular time. Let's look at a couple of other models. We'll do this carefully. First, Icon.
21.7 yellow cross.
Hey, John. All right.
Yeah, icon.
Track is everything.
Sure.
All right. The Canadian model.
You gotta put a tariff on
Half an inch.
that.
Okay. You can go to UK Met. I don't know if we're far enough out yet. Not looking good, John. Let's go to 60.
What I don't get is the delight with which you say
No,
that.
yeah, it's not delight. It's just. But hold on. There's the method. The reason I'm doing this. Let's go to UW-AOS, and that's the wrong time. Let's go forward to. I don't want to give the punchline. That's too far out. It's Thursday. That's fine. It's Thursday. Okay. And now let's look at the AIFS.
Okay. The one in which you have great confidence now. Yeah.
All right.
Mm-hmm.
So, you know, again, I'm not saying anything. Just saying there's a possibility.
Saying it.
Here we go. Here,
A long time to not say
GFS,
it.
right? Long time. And if you look at the GraphCast, which is sort of a cousin, if you will, and actually we don't have precipitation amounts for that, unfortunately, for snow.
cold
I forgot
enough.
about that.
32 degrees.
But it will be cold enough for snow, and we do get, I think, at least 4/10, 5/10 of the liquid precip. But again, the ground is going to be warm, so a lot of what
Yeah.
falls will melt. You can be sure of that. But it looks like midweek could be a really interesting event. Last thing I want to do, because I promised this 2 weeks ago, and I've still been tracking this, is to go to our spring break a week from now. What's the forecast? It looks like things are beginning to lock in, things are beginning to gel a little bit in the forecast. This is, again, a series of maps that show the forecast from the CFS. I didn't switch to the GFS as I initially planned to do. That goes back at least 3-4 weeks ago. Valid, same time. So this is the forecast initialized back on the 21st of February for next Friday's Weather Watch. All right, not at 18Z, but at 12, 6 hours for next Friday's Weather Watch. Let's just quickly step ahead because I know time's over. But again, the forecast flops around. There is no continuity in the forecast until we get to like the last 4 or 5 frames of this. You can see that. We're gonna be cold. Are we gonna get snow next Friday? No, it's gonna be warm. No, it's gonna be rainy and warm. Warm again. Warm again. So, warm. Just missed a snowstorm. John is miserable because he's watching that happen just to the southeast. Cold. Yeah. Rain. So, whatever. But then as we get closer to the end of this, again, keeping a hint of a cyclone passing to our south. But then here, as we get to 240 hours, the notion of just being chilly with a storm somewhere in New England and our being sort of in between weather systems. A couple more clicks I think we have left. So as we get closer to this, obviously more data, things are coming together. And then we go back to that. So we just flip back and forth between the last 2 frames, the first and last frame, sorry, 192 or 180 and 672. Again, the last frame, the 180, was initialized at 0Z last night. I've been collecting these, and Pete's been nice to put them all together to this loop to look at the forecast. And we'll see what actually verifies next week. But
Let's actually look pretty good.
this is, some say it doesn't. It looks pretty good. We don't even know if these are the same weather systems, right? Who knows what's going on? This is, I mean, how many? We don't know if this is the same planet for that matter, right? So. Again, I just do this more out of interest in just seeing how, when do we see weather patterns coming together and being a reasonable forecast. We saw at the very beginning of Weather Watch today that AIFS success, with a 8-day forecast or so, a pretty decent forecast. We're now 7 days out. Have we kind of locked into a solution that's going to make sense for next Friday being relatively sunny? Probably if we do have any snow cover, it could be a little bit chilly. I haven't looked at this carefully. Is this the weather system that just passed by and gave us the snow? That could be it. So as we're getting closer in time, we might expect this to be a more realistic forecast. And this is just getting up to spring break. What happens after that, I haven't even looked at, because I'm just curious about what's this day gonna look like a week from now. So anyway, thanks again, Patrick, for a really great discussion of the severe weather potential in this weather system in the mid part of the country. This is an active day, and I think you just led a really great discussion of that. Thanks, John, for looking at those diagnostics from the PG Omega equation, and Pete for running the whole show. Have a wonderful weekend.
All right, thank you.